Good evening, Internet. I am Matt Buyak, and in this video, we'll take a look at the 17th problem from the Project Euler Problem Archive. So this problem asks us to calculate the number of characters in the letters 1 through 1,000 if they are written out as English words. It makes a few clarifications indicating that we should omit spaces and hyphens from our total, and also that we should use the British convention of putting the word "and" after the word hundred. So 101 rather than 101. So let's get started. As usual, we'll copy our template directory to make our problem directory and open our main.cpp. I think the only wrinkle in my approach that's worth mentioning is that I'm going to start by actually constructing all of the strings in question and then measuring the length of each. But we don't actually need to do that. And so then after we have our answer, I'll improve our solution by just calculating the lengths without constructing the strings themselves. Okay, so let's see here. We want to say uint32ti, and we'll say for I equals 1, I less than or equal to, actually, let's say less than 1,000. 1,000 is kind of a special case, and so we're going to handle that separately. Plus I. Okay, and we'll make a note here, handle 1,000 separately. Okay, and I'm just going to fill in some comments here to outline our approach. So we'll say if number is greater than 100, print hundreds digit. If number is between 10 and 19 inclusive, handle that case. Otherwise, print any other two-digit number. So this is just a rough outline of what our approach is going to look like. Between these two, we need to say, check if we need to print and. Okay. So we're going to need a buffer to write our numbers into. And so we want an upper bound for how big our strings can be here. And so I believe the largest would be something along the lines of 700 and 77 or something like that. 7 and 3, I believe, are the longest strings for single-digit numbers. You'll notice 1 and 2 are both 3 digits. 4 is 4 digits. 5 is 4 digits. 6 is 3 digits. Wait. Yes, 8 is also 5 digits, so that would also work. But none are longer. In any case, you can see that at most we have 5 words, all less than 10 in length, and so we can just do something like buffer 120, and that will be plenty large enough. We can be a little bit wasteful in our memory usage here because we're only talking about 100 bytes. It's basically nothing. So that's going to be our buffer here. And then we want to store all of the strings that we'll need in a form that will be useful. And so let's say char ones equals, excuse me, well, let's do const character pointer ones, and that's going to be 1, 2. We should actually add an empty string for 0, 3, 4, 5, 6, 7, 8, 9, and not 10. You'll notice that these are only the ones digits. So in particular, we're not going to have, you might have 21, but you can't have 2010. Well, you can, but not meaning a 3-digit, or excuse me, a 2-digit number. And so 10 is not included in this. Okay, and then we will need tens. And so we'll say, again, we need a blank string there, and then we'll say 10, 20. 10 actually, we're actually not going to include that in here because we have to handle the numbers between 10 and 19 inclusive a little bit differently. That is, for a number like 21, we can separate it into the tens part and the ones part. And so we say, it's a 2 and a 1, so the 2 corresponds to 20, the 1 corresponds to 1, and there's a direct mapping in that way. But for, say, 17, it's not 10-7. It's 17, and so we have to handle those separately. So I'm not going to include 10 in this list. And again, we don't include 100 in this list. Okay. And then we'll need teens. As I mentioned, this is going to be a bit of a special case. So we'll have 10, 11, 12, 12, 13, 14, 15, 16, 17, 18, and 19. Okay, so that should be all we need. You'll notice that for the hundreds digit, we can use these again because we'll just have 100 or 300 or 600 or whatever. Okay. We'll also need a pointer to our current location in the string. So we'll just say cur equals address buffer 0. All right. And I think that's enough. We should be able to get started on our solution. So we'll say if I is greater than or equal to 100. Then we'll say cur plus equals sprintf, %s, ones, and that's just going to be I divided by 100. So again, this ones list is the strings for 1, 2, 3, 4, etc. And so just dividing our number by 100 will give us the 100s digit, and so we can just use the appropriate string. Oh, I need to, there we go, okay. So yeah, the first argument should be the destination buffer. And then this function will return the number of characters written, and so we can update our current pointer into the buffer. Okay, now if we've written a hundreds digit, we may need to follow that with an and. But only if it's not a multiple of 100. That is, we would write 102 or 101, but we wouldn't write 100 and 0. We would just write 100. And so we'll say if I mod 100 is, actually we can just, if I mod 100, cur plus equals sprintf. Yeah, this should be fine. And one note about this. This is the remainder when dividing by 100. And this is just checking if that remainder is non-zero. Then we're going to add the word and in here. Yeah, we'll need a... keep leaving off that first argument. Okay. All right, so now we need to handle the teens specially. So we'll say if 10 is less than or equal to I, and I is less than 20, then we're going to handle the teens. Oh, excuse me, this should be, we want to say I mod equals 100. That is, we've dealt with the 100s digit, so now we're going to just remove that, take the remainder when I is divided by 100, and just keep that for the rest of our... no, this will not work because we need to be able to increment I. So let's do this. Okay. All right, so now we can say cur plus equals sprintf, cur, and this is going to be %s teens, and that's just going to be n minus 10. Okay. And then so we'll say else. We'll need to print the tens digit, so we'll say cur plus equals sprintf. And we'll say tens, n divided by 10. We'll say n mod equals 10, and then cur plus equals, we have to be a little bit careful here. I believe we need an, if n, and in fact we need the same here. Else if n, because it's possible that again if n is a multiple of 100, that it will be 0 here, and then we won't be printing anything farther. Let's just do it this way. Okay, so we have some problems. It would help if I added. Now this is strange. Oh, I'm not resetting. Here we know we need to. Do this here. Okay. I've forgotten to print. This should be 100. Okay, so looking over here, we have, for example, 982, 981, 980. Let's check some up here. 940, 939. Let's check, okay, 900 flat appears as expected. 901 as well. 914, 915. 920, 920. Okay, everything seems to look correct. So then we can say total len, and we'll say equals 0. And then we'll say total len plus equals strlen buffer. And then we'll say total len plus equals strlen 1000. Printf total length equals total len. Doesn't seem to like that. possibly need to include string.h. Uh, 21,124 appears to be the answer. Now, before we check that, let's perform some optimizations. Okay. Okay, so instead of actually, doing this cur plus equals sprintf, etc., we don't actually need to do that. We can just do something along the lines of total len plus equals strlen 100 plus strlen ones n over 100. We can get rid of the buffer and cur. All right, total len plus equals strlen teens n minus 10. So the reason why I did this first step of actually printing out the strings is that it's much easier to see if you've made a mistake if you can visually inspect the strings. If I were just printing out the answer without any sort of output like this, we wouldn't have any indication at all whether we've made a mistake or not. And there are a couple of simple mistakes that you can make in solving this problem, and so having a double check like that is always a good idea. All right, let's do tens n over 10. And this is just going to be strlen ones. We don't need this anymore. We don't need this anymore. And yes. It seems to not like this. Yes, we have to remove that also. Okay, we get the same answer. Great. So now our program is a little bit more efficient in that we're not actually having to do these string operations. We can just calculate the length. And actually, there's one more trick that we can do. I just want to show you something real quick. If we do strings solver pipe grep 70, you'll see that the string 70 does indeed appear in the program. But we actually don't need that string. What we really just want is the length. And so there's a neat trick that we can do here. If we change these to arrays of uint32t. And make them constant. Okay, and then we can say sterlen. Actually, we can make this one 0, and this one sterlen like so. Because we actually don't need the string itself. We really just care about the length, right? And so a little bit tedious, but be done in just a few moments here. It's 0, 0. Okay, so now instead of having to do these sterlens down here, we can just do this. We've already calculated the length. We'll probably also want a constant here, const uint 32t. We'll have 100 len equals sterlen 100. And const uint 32t and len equals sterlen and 1,000, excuse me, 1,000, we'll just call it 1,000 equals sterlen 1,000. Okay. So we can get rid of that. We can get rid of these. We can replace this with 100 len. Replace this with and len. We can replace this with just teens. Okay, so now we shouldn't have any sterlens after this point. So yeah, they only appear up here. Let's go over here. It does not like me. Oh, didn't actually change this. I made a typo down here. Okay, and we have the same answer. And now I believe if we do strings solver pipe grep 70, we can see the string 70 appears nowhere in our program. And so we've actually eliminated the strings themselves, don't appear anywhere in our program. We don't have to iterate over the string to find its length or copy the string from one buffer to another or anything like that. We're just working with the lengths only. Okay, so we've now come up with the same answer 3 different times. I think it's time we verified its correctness. So if we go over here to the archive and we check here, we can see that indeed that is our answer. And so that will be it for this video. In the following video, we'll be continuing with problem number 18.